Good day, everyone. Today, I am showing you some dirty little secrets. Test secrets, that is. Saving those who want to be safe. As I told you guys before, you know, it's all up to you. You're going to do it or you do or you don't. I hope you do, but if you don't, you got yourself to blame. What's on the test? Polynomial operations, number facts, number types, factoring, graphing, projects. Oh, and forget about equations. Can't forget about that. That's what you gotta contend with. But you gonna thank me later once we get to all of this. Yes. So, the math wash, which is a review, that's a grade, which I'm grading you for a quiz and a final participation grade as well. Because after Monday and Tuesday of this week, it's, it's all about tests, demonstration, my test, fact skills, error analysis, ANET, extra things included, Graph and Desmos, ACT paper version. So you got a lot to do. So need for you guys to be about it. Reminders. Focus on mastery of topics instead of doing it to think that you will do well. Passing tests can assure you that you will get a passing grade. Like if you fail because you don't do homework, but for some reason you pass my test, guess what? You passed the class too. So, and that's because any zeros or any assignments, excluding participation, I could replenish those, but I won't replenish participation points. All right, our Kahoots are closed at this moment. No homework. Tutoring is also closed, so none of that extra stuff. Testing procedures. All right, guys, you will have assigned seats. I will put you in alphabetical order, so no one won't be, how to say, you won't be sitting with your peoples. No devices for the demonstration on the ACT part. So you won't have your Chromebook or your phones doing those sessions of the test. No compliance to those procedures will lead to academic dishonesty. As a result, a 0. Also, you are not to talk at any point during that test. Just like the ACT that you guys are going to take, if you were talking to someone or doing anything like that, you're going to get removed from the testing center and your scores will not count. So that's a reason why my tests are heavily monitored. I will be watching you like a hawk. Attendance is a requirement to receive a grade unless valid excuse is well noted prior. So not if you just miss a school just because you wanna, guess what? That's gonna hurt you at the end. So it'd be best for you if you gonna show up. Don't miss no days for these 2 weeks, especially. This is pretty much the end of the first 9 weeks. Be here so you get your makeup work and stuff together. For other classes, my makeup work is done with. So I see maybe I got 3 Kahoots still open. I'm about to shut those down too. You are smart. Watching this video with effort will allow you to pass. It will also let you know the test, also the test types though. By you watching this video, you're going to be well good to go for my test and a net test. Math facts. So let's talk about polynomials. Polynomials are pretty much an expression with exponents greater than or equal to 0 and non-negative. So that's something you should recall. You also cannot have no division. Or this or that. You can't have that going on. So you should know this by now. I already explained to you as to why, because exponents gotta be 0 and above. Alright? And of course I gave you examples from the previous video, so you may want to check those out about polynomials. So by now you should know. And we're going to keep it going. Imaginary numbers. I know it's been a while since we touched on it. Well, we touched on it when solving for equations. We know that if you have a negative number, you're going to get error, and you have to write it as 5 as I plus or minus. We know these things. Right? Project Facts, our number system. The name of our number system is called Hindu Arabic. Who created zero and its purpose and the ends to make numbers bigger or smaller, but bigger. So if you was to say bigger, that's all you really need to say to me for your test. Give one comparison and contrast of the U.S. and the Latin American mathematics from your project. So if you did project 2, you know part 5 has a compare and contrast thing that you can do. So you know that. So the comparison is, you will say, well, they both got in common. When we compare, both use Hindu Arabic. US, write that 7th like this. Latin America, write their numbers for 7 like this. So that's one way of saying it. You could also say, in the US, they use 5.2 as a decimal, but in Latin America, they use it as 5.2. So there's many ways you can answer that question, but that's something that I will be asking you. So please definitely make sure you understand that part of project too. All right, the precise definition of mathematics. You definitely gotta know this. The technique to explain, understand, and manage reality specifically by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. I will be asking you this. You saw on your quiz, you saw on your projects, and here I'm talking about it again. I've been talking about this for a while, and you're going to see this on your test, so know this definition very well. I may put a true or false statement on there. True, false. I may say fill in the blank. It could be one of those two things. Or I may add one more thing and I may just take a word and explain the meaning. So I could do a lot of things with that. So those are the three things that I could do for this definition on a test. It may be true, false. It may fill the blank. You may have to explain the meaning of these words. So you may want to review. All right. Polynomial operations. In all our seriousness, for my test, A for ANET, you really got to pay attention to division. But that's an easier way of doing division that I kind of kept away from you guys because I kind of just didn't want you to know it at the moment because I want to see that division work. All right, so factor theorem. Let P be a polynomial function in X and let A be any real number. If A is 0 of P, then X minus A is also a factor of P. For example, if 3 is a 0 of this function x squared minus 6x plus 9, then x minus 3 is a factor. Like for example, if I was to say if negative 2 is a 0 of x squared plus 5x plus 6, then x plus 2 is a factor. So again, we know a thing too about zeros, going back from solving equations. We worked with it a little bit. I taught you other words for zeros. Even we did it with graphs as well. All right. But for some of my questions, we're going to be using, doing factors and zeros to kind of take care of things. All right. So, however, on my test, I definitely got to see that long division algorithm. I got to see it. I got to see you put in the work. So let's do it. All right, because I'm limited on space, I may be doing the work a little bit sloppy on this right hand side. But we know 50k third divided by 5k is 10k squared. So that's my quotient. Let me put my quotient in a different color so you guys can see it. All right. Now again, because I don't have a whole lot of space, I may be shortcutting this a lot. So 10k squared, because I'm multiplying, because I did the division, now I got to do the multiplying. 5k minus 4. So when you multiply, you get 50k cubed minus 40. But we know we had to change signs because that's subtraction. So it will be minus 50k cubed plus 40. So let's do that right here. No, oh, I'm tripping. 40k squared. Because k squared times 4 is, well, 10k squared times 4 is 40k squared. So that's what I was tripping on right there. All right. We cancel things out. And guess what? We got to do the process again. So I'm going to erase, because I already did that process once. And because I don't have room to do all the repeated processes. All right. So 40k squared divided by 5k. So from there, 4 divided by 5 is 8. I get 8k. And that's positive 8k. So positive 8k. So 8k, 5k minus 4. So when I multiply that, that is going to be 40k squared. I'm trying so hard to make that look like a k, but I see why people will struggle with that k. Okay, there we go. So 40k squared minus 32k. Again, I'm just doing the multiplying process. And this is part where I gotta change my signs, because I'm doing the subtraction. Alright. Alright, so let's subtract. So that disappears. Negative 35 plus 32 is negative 3k. And I bring down that minus 7. Alright, let's do it once more. And we notice usually wherever exponent is front usually tells us things, tells us how many zeros we may get or how many times we may repeat the division factors. Usually, that is. Alright, so negative. Alright, let me check this out. I'm just checking my division. Make sure that we are on point here. And guess what? I believe we are done, actually. So let's figure this out. Okay. So right now we are done, and this is how we know that we are done. How do we know we are done? Because let's go ahead and do this. Negative 3k divided by 5k. So guess what? When you try to divide that, guess what? You're left with a fraction. And anytime you're left with a fraction, guess what? You can't do that because usually when you're doing long division, doesn't matter if you're doing polynomials or not, you're always looking for a whole number. So you could leave it as that. And you don't get a whole number with that. You get a fraction. So guess what? You are finished. And your remainder is this. Now ANET. On ANET, this is what they want you to do with well, I told you guys about this, not just only on ANET. Even the ACT is going to ask you to put your final answer in this form. Take your remainder, put it on top, negative 3k minus 7 over the factor, 5k minus 4, and then your quotient, 10k squared plus 8k, it's going to be right there. So let me erase the little arrow sign. This is what they want your answer to look like when you take ANET and when you take ACT. Your quotient and your remainder. And your divisor. So you got all your pieces together, and that's what they will want to see, just like that. So once more, anytime you are left with a fraction like this, you can't really do that. You could, but for ANET purposes and my test and ACT, they're always looking for whole numbers. All right. All right. So find the remainder of this when it's divided by x minus 2. So guess what? This is the little secret I am going to share with you. You don't have to do that long division algorithm that we just did because that's you find the remainder. So to do that, you have to do the following. The x minus 2, that's a factor. So we know if x minus 2 is a factor, the 0 of x minus 2 is just 2. So what you're going to do in this particular case is just plug into what you see. And this is how we're going to find out for the remainder. Not the quotient, but the remainder. All right. 2 cubed is 8. 2 times 8 is 16. 2 squared is 4. 4 times 4 is what? 16. And then from there, 2 times 2 is 4. And then 4 plus 4. So 16 minus 16 cancels away. 4 plus 4 is 8. And that means your remainder is going to be 8. And that's all you have to do when it asks you for remainders like that. See, and we did that just by using zeros. Alright. So suppose you have a polynomial that looks like this. Find the value of k so that x plus 1 is a factor of p. So we know that x plus 1 is a factor. So to do this, you got to take the 0 of that, and the 0, instead of being positive 1, is going to be negative 1. From there, plug in all the negative, plug in for every x you see. So x cubed plus kx squared plus x plus 6. I got to find out what k is. To do that, we know that negative 1 cubed is just negative 1. And we know that negative 1 squared is going to be 1, but you have k, so that's just going to be 1k, or just k if you want to. You can leave it as k. And negative 1 to the power of itself is just negative 1 plus 6. Now we got to figure this all out. And from there, you just got to get x by itself. Well, k by itself. So negative 2 plus 1k plus 6. So this is k plus 4 equals 0. And then if we go there, k equals negative 4, because I moved 4 to the other side. And so k is negative 4. Oh, ain't that? You may be faced with something like this. ACT, you may not be faced with something like this on the ACT. You may or may not. I don't think they'll put something like that. But be prepared in both ways. On my test, I won't put that on there. Alright, find the value of k so that k is a factor of q. So, with this, let's just, since we know that x plus 2 is a factor, well, 0 is going to be negative 2. So from there, plug in 2 times negative 2 cubed plus negative 2 squared plus k times 2, well, negative 2 that is, plus 2. So we know negative 2 cubed is negative 8. So 2 times negative 8. And we know negative 2 squared is just positive 4. And we know that negative k times negative 2 is negative 2k plus 2. So 2 times negative 8 is negative 16 plus 4 minus 2k plus 2. And this is part where you just say equals 0. Because you're trying to solve for k. So 4 plus 2 is 6. Negative 16 plus 6 minus 2k equals 0. So we know that negative 16 plus 6 is negative 10 minus 2k equals 0. And then if we were to move that around, we get negative 2k equals positive 10 because I moved 10 to the other side. And then if I divide it by negative 2, k equals negative 5. And that's how you solve such a problem like that. So again, you're going to probably see this on ACT. You're probably going to see this on ANET. It'd be best for you to know this to a science. Imaginary stuff. The imaginary stuff is pretty straightforward. Imaginary numbers are not on the graph. They take away from zeros as factors. For example, if you have 4 zeros but 2 imaginary numbers, then you end up with 2 zeros. Simple facts. Something we talked about beforehand, so. Factoring techniques. So, on my test, you definitely must know that negative 81, well, 81 and 25 are perfect squares, right? 81 is a perfect square of 9. 25 is a perfect square of 5. So, even though this is a difference of squares, so you go get 9 or plus 5, 9 or minus 5. And that's on my test and on the ACT. So you definitely must know this one. X cubed minus 64. You only have to know this for my text. So you know 64 is the cube root of 4. So that's going to be x minus 4. And in parentheses, and we know if we took one x, it's going to be x squared here. And then the back, we know it's going to be positive 16. And we know in the middle, instead of it being minus, because you already got minus in the front, in the middle, it's going to be 4x. And this is just stuff that we did already. So refer to those videos if you still are struggling with this. Alright, so by now we know the factoring cases, but on my test, I am going to caution you to know that you want to also solve them too. So it's not just going to be, okay, just a factor. You're going to factor and solve. Then you're going to graph too. So it's a lot you got to do. So let's factor this. This is case 1, factor by grouping. So in the first parentheses, pull out a p squared. And then from there, we're you're left with a 2p plus 5. So I know wherever I got in this first parentheses have to be in my second parentheses. So 6 and 15. I know that they have a 3 in common. So that's going to be p, 2p, that is, plus 5. Like I always use the derivative property to check my word. And when I do that, I get back this guy here. So from there, p squared plus 3 and 2p plus 5. So that's the factor form of this. But if I was to solve this, which of course I'll be asking you to, subtract 3 from both sides, take the square root. You know you can have a negative 3 in the square root, so p is going to be plus or minus I, imaginary, square root 3. But then here, 2p plus 5 equals 0, minus 5, minus 5. 2p equals negative 5, divided by 2, divided by 2, p equals negative 5 halves. And that's all you have to do. Just like that. But this is a real 0. This is imaginary. So I'm going to erase a little bit, because I need space. So the multiplicity m is going to be 1, because they only repeat once, and no exponent outside. Let me rewrite that. The multiplicity means how many times the factor repeats itself. And they both are 1 because they repeat only once. All right. Factoring. You know this is case 2. So we know two numbers multiplied together gotta give me positive 10. And the same two numbers gotta give me negative 11. That's negative 10, negative 1. Multiplied together gives me positive 10. But the same two numbers give me negative 11. So x minus 10, x minus 1. That's factoring, but if I was to solve it, x minus 10 equals 0, x equals 10, x minus 1 equals 0, x equals 1. And those are my x-intercepts or my zeros. It is imperative you know that the answer of an equation is known as a zero, but also known as an x-intercept. You must know that. All right, here, this is swing method because we have these word numbers and we know we multiply. So once we multiply, we know 2 times negative 9 is 18, so we repeat it again. We write All right. And we already know our numbers. We know x minus 6 and x plus 3 are my winning numbers there. All right. And I went a step ahead because I didn't want to write out two numbers multiplied together gives me negative 18, and two numbers added together gives me positive 3. By now you should know how to do that. You should have that down to a science. So that's why I didn't write it. But if you don't, that's okay. You just keep practicing it. It gets better. Okay, from here, divide by 2, divide by 2, negative 6 divided by 2. Just give me the answer, so it's going to be x plus 3. And then over here, that does not, so swing it. It's 2x plus 3. I'm sorry about that, y'all. A little bit of technology issues. But you guys could replay that last part and just solve the equations. So here, I know this is case 4. How I know this? Because I got a perfect square in the front and a perfect square in the back. So I know 25 is the perfect square of 5. So that's 5x. Because I know that I have a negative here, I know that two negatives multiplied together is going to give me a positive. So that means I should rewrite it like this. X, 5x minus 4, 5x minus 4. Or another way of rewriting this is 5x minus 4 square. And the multiplicity is just 2. You're going to definitely see it on my test, and you definitely got to know the multiplicity of it. And don't forget, you got to solve, but I'm not doing this in this video because you should know how to solve this from here. Look at the other videos if you quite don't understand. Equations. Sometimes, as I have taught you guys before, you don't have enough time to sit there and solve equations with speed. Because on your ACT, you got 60 seconds, so you got to be fast. And I taught you how to do that. So, remember this linear equation that I showed you in the classroom weeks ago? Suppose I did not know how to solve it. Well, guess what? If you put in decimals, you get something that looks like this. You see that line in purple? That's the 0. The x-intercept, again, is another word for 0. And those are your answer. Those two words are saying your answer is 3. That's all you have to look at. So on my test, I will put some stuff on there for you to do. And with decimals, so you have to do that for all tests. My test, ANET, and ACT. So you definitely gotta know what's up like that. All right. All right. So suppose if you didn't have time to solve, you got time for this. And suppose you're taking ACT, you definitely don't have time to solve from lightning speed. Guess what? Put it as you see it. Put it in as you see it. From there, I see my zeros, or my x-intercept, or my answers are negative 2.5 and negative 1. Those are my answers. So again, when they say zeros, zeros are x-intercept. They also are roots, all saying the same thing as answers. The graph is an answer to the equation. So remember that. Uh-oh, Miss Al, what's this? Don't worry, I'll show you how to do this in class. So in Desmos, to type this in, you're going to use 1 divided, type in just like that, x. And the key you're looking for is that a square key, and you're going to get 1 over x squared in Desmos. So anyway, you again, on any test, when they say solve, and I know for a fact I haven't taught you how to solve this yet algebraically, but I taught you how to solve any equations by using Desmos, and when you do that, you should get something that looks like this. Sometimes you're going to have 2 lines, sometimes you're going to have 1 line, but whatever the vertical line is, the vertical line is telling you where your x-intercept is. The vertical line tells you your answer. Suppose you had something like this. I'll show you how to put that in too. Guess what? Put in Desmos exactly as you see it. And you should have something like this. X equals 4. That is your answer. This vertical line is telling you what your answer is. Graphing characteristics of polynomials. So, on my test, you're going to have to graph. Graph as you see it. Give me the real zeros. Here, I'm going to ask you for the multiplicity. And the multiplicity is just going to be 1. And again, those zeros are those x-intercepts you see. You see them. So if you can't see it through this video, put in Desmos, and you'll be able to see the graph, and you will see the x-intercepts. And y'all, that's pretty much it. If you could do that, you're going to be alright.